All right, welcome everyone. In this explainer, we are literally going to lay the groundwork for your entire IT career. We're going beyond the software, beyond the code, and getting into the physical stuff, the cables, the hardware, and the critical documentation that makes it all work. Think of it this way. This is the bedrock, the foundation that every single secure, reliable, and scalable network is built on. Ready? Let's get into it. Okay, I want you to picture this, because trust me, this will happen at some point. It's your first week on a new job, the pressure is on, a critical system is offline, and you're faced with this, a complete nightmare of tangled, unlabeled cables. This isn't just some made-up scenario. It's the reality in a lot of poorly managed environments. That sinking feeling in your stomach, that panic of not even knowing where to start, yeah, that's exactly what this chapter is all about, preventing. So how do you fight that chaos? How do you bring order to that mess? The answer is you fight it with process, with standards, and with a real strategy. Look, the difference between an amateur and a pro isn't just knowing how to fix a broken thing. The real pro knows how to build a system where that kind of chaos just can't happen to begin with. This chapter is your guide to becoming that pro. So first things first, we've got to tackle the infamous spaghetti monster. And we do that by building a solid, predictable digital foundation. And listen, this isn't just about making things look neat and tidy for a photo. It's about engineering an intentional structure that the network's entire performance and reliability depends on. Now, what's really cool here is the standard itself, TIA/EIA-568. Think of this as the official industry blueprint for cabling. It's hierarchical, meaning it has clear levels like a pyramid, and it's built on a star topology. And the whole point? It's simple, but it's so powerful to create a network foundation that's predictable to manage, super reliable, and crucially scalable so it can grow with the business. So let's follow the journey of a single connection, right? Where does it start? It all begins at the entrance facility. This is where the outside world's connection hits your building at a point we call the demarc, the demarcation point. From there, it goes to the main distribution frame, or MDF, usually in your main server room. Then, if it's a big building, it might hop over to an intermediate distribution frame, or IDF, before, finally, it gets to the wall jack right there at the user's desk. See? Every single step is logical and planned out. And this right here? This is a perfect example of that level of standardization. When you walk into a professional data center, you'll see these big racks of equipment, and the standard height is 42U, or 42 rack units. That's about 6 feet tall, and this isn't some random number. It's designed so that equipment from Dell, Cisco, HP, it doesn't matter, will all fit together perfectly. Okay, here's another number you absolutely have to burn into your brain. 100 meters. That's the maximum distance for what we call horizontal cabling. That's the cable that runs from the switch in the closet all the way to a user's desk. And this isn't just a suggestion, it's a hard rule. It's a fundamental design constraint that tells you exactly where you need to put your data rooms and your closet. Okay, so if structured cabling is like building a perfect highway system, what good is it if you don't have a map? Well, that's where network documentation comes in. Without it, you are driving completely blind. I'm telling you, good documentation is one of the most critical and honestly one of the most overlooked parts of a healthy network. And let's be super clear about the business impact here, because that's what it comes down to. With good documentation, you get clarity. That leads to efficiency, faster repairs, better security because you actually know what's on your network. And without it, well, it's chaos. It's longer downtime. It's massive business risk. It really is that black and white. So what's actually in this map? What are we talking about here? Well, it's basically a living blueprint of your entire network. You've got network diagrams that show you how everything plugs into everything else. You have a complete inventory, every piece of hardware, every piece of software. You've got records of how all your IP addresses are used. You've got contact info for all your vendors. And maybe most importantly, you have the internal policies and standards that dictate how the whole thing is supposed to be managed. All right, this next part is where we really level up. This is where you go from being just a technician to a strategist. Look, having a perfectly cabled and documented network, that's the foundation. That's table stakes. Managing its growth and its change over time, that's what takes you from being a reactive person who just fixes broken things to a proactive strategist who actually anticipates problems before they even happen. And this is a core strategic process. Configuration management isn't something you do once and then forget about. No, it's a continuous life cycle. It always starts with discovery. You got to know what you have. Then comes version control, so you can track every single change. From there, you're constantly monitoring the system. You want to automate tasks wherever you can to cut down on human error. And finally, you audit the whole process to make sure it's actually working the way it's supposed to. Now let's talk about two key metrics that help you essentially predict the future and recover from the past. First, you've got MTBF, mean time between failures. This helps you predict, on average, how long a piece of gear should last before it breaks. Then you've got MTTR, mean time to repair. This measures how fast you can get things back online when they do break. And as a strategist, your job is always to make that MTBF number as big as possible and that MTTR number as small as possible. And how do you do that? How do you make your network resilient? Well, it all comes down to this idea. A single point of failure, we call it a SPOF, is any one component that, if it dies, takes the whole system down with it. The strategic goal is to build in redundancy, having backups, duplicate parts, extra connections, so that no single failure is a catastrophe. That, right there, is the heart of building a resilient network. Okay. So we've hit the big strategic ideas, right? A solid physical foundation, a clear map to guide you, and a process to manage all the change. So now let's get tactical. Let's talk about what you need to be looking for as you dive into the actual chapter reading and how to connect these big ideas to the nitty-gritty details. So as you're reading, I really want you to focus on these key distinctions and processes. First, make sure you really get the different roles of an MDF versus an IDF. Next, cement the difference between MTBF and MTTR in your head, what they measure and why they matter. Pay super close attention to the formal change management process. This is your playbook for making changes without breaking things. And finally, get comfortable with the key business documents you're going to see, like SLAs, service level agreements, and SOWs, statements of work. These are the actual contracts that define the promises you're making to your users. So, I'm going to leave you with this one final thought to chew on as you read. Is a network ever really finished? Is it something static, like a bridge that you build and it's just done? Or, and this is the key, are we the caretakers of a dynamic, living system that is always changing, always evolving, and demands our constant strategic care? I think the answer to that question is going to shape your entire career.